finally, I want to do a little bit of a summary. So a tactics box from the book really summarizes the most important takeaways of this. I've been trying to do a lot of detailed working with free body diagrams and everything else to continue to reinforce the important aspects of working with forces. But here is just some big picture things specific for pulleys and ropes or strings. So first, we're always considering that our ropes and strings are massless unless you're told otherwise. Your pulleys are going to be frictionless and massless unless told otherwise, which we'll see in a couple of chapters. Once you have a pull, some sort of force on one end of the rope, the tension in the rope equals that pulling force, right? You don't have to, it's not more subtle than that. Constant force through the whole thing. If you have two objects connected by a rope, whether they are horizontal or vertical, the tension is the same at both ends. And what that gets to mean is that you can have them as if they are directly interacting with each other as a Newton's third law pair. Finally, whenever we have a rope passing over a pulley, the tension isn't affected. All it is doing is changing the direction. So that's the idea of the ideal ropes and pulleys. So my summary, rather than the book summary, is that we are always going to be treating strings and ropes as ideal, which means they are massless. And that means that the tension is going to be a constant throughout. That also means that we are going to be able to have two objects connected by a rope or string interact as if they're in contact. And I keep saying this because the book literally writes it on free body diagrams, as should you. And for pulleys, these are just going to be redirecting. I say forces here, but I mean tension. And that we don't worry about the mass or friction of pulleys, at least right now. We have to get to rotation and torque before we can understand what's going on with that. So not that hard of a topic, but a really nice application of interacting objects and Newton's third law.